G parameters of two-port circuit, or it is also called inverse hybrid parameters of two-port circuit. The equations for G parameters are I1 equal to G11 V1 plus G12 I2, and V2 is G21 V1 plus G22 I2. These are the two equations. In matrix form, I1 V2 is equal to G11 G12 G21 G22. This is 2 cross 2 matrix, and then V1 I2. This matrix is called G matrix or inverse hybrid matrix. Now, if I take the inverse of this matrix, into I1 V2, then on the right hand side we have V1 I2, and this matrix is similar to, or this equation is similar to V1 I2 H11 H12 H21 H22 I1 V2. So by comparing the equations 3 and 4, we can write that this is basically H matrix denoted by, say, capital H, and this one is G matrix denoted by capital G. Then we can write that the H matrix is inverse of G matrix. Similarly, we can write that G matrix is inverse of H matrix. So in this way we can make the conversion from G to H matrix and H to G matrix. Now let's draw the equivalent circuit. In fact, before equivalent circuit, let's define G11. G11 is I1 V1, I1 over V1 when I2 is 0. It is the ratio of current to voltage, so its unit is ohm, mho, and it is called input conductance because it is the ratio of input current to input voltage. Now G12 is I1 over I2 when V1 is 0. V1 is 0 means port 1 is short circuited. It is unitless quantity because it is the ratio of the two currents, and it is called reverse current gain. Why it is called reverse current gain? Because it is the ratio of input current to output current, or current is transferring from output port to input port. That's why it is called reverse current gain. G21 is V2 over V1 when I2 is 0 or port 2 is open circuited. It is the ratio of voltage to voltage, so it is unitless quantity, and it is called forward voltage gain because it is the ratio of output voltage to input voltage, or voltage is transferring from input port to output port, and it is called forward voltage gain. And the last is G22. G22 is V2 over I2 when V1 is 0. It is called output impedance because it is the ratio of output voltage to output current when input port is short circuited. Now let's draw the equivalent circuit for the equations of G parameters. Equivalent circuit. In the first equation, on the left hand side we have current. So on the right hand side, the two quantities are also current, and sum of current is possible when the two components are connected in parallel. Current of port 1 is I1 and voltage of port 1 is V1. So this current G11 V11, so in fact G11 into V1, for this will connect a conductance between 1 and 1 dash. Its unit is mho. And then second quantity is G12 I2, and I2 is current of port 2. So to bring the current I2 at port 1, we need to connect a current dependent current source in parallel with G11, and the value of this current source is G12 I2. Now in the second equation, on the left hand side we have voltage. So the two quantities on the right hand side are also voltage, and sum of the voltages is possible when the two components are connected in series. Voltage of port 2 or output port is V2, and here we have the drop across G22. So G22 is impedance connected here. Its unit is ohm, and the first quantity of the second equation is G21 V1, and V1 is the voltage of input port or port 1. So to bring V1 at port 2, we need to connect a voltage dependent voltage source in series with G22, and its value is G21 V1. So this is the equivalent circuit for equations of G parameters or inverse hybrid parameters. Now we will make the conversion, or in fact we will write Z parameters in terms of G parameters. So we have the two equations of G parameters, and equations for H parameters are V11, in fact V1 equal to Z11 I1 plus Z12 I2. This is equation 3, and second equation is V2 equal to Z21 I1 plus Z22 I2. Now we will modify the two equations 1 and 2 in the form of 3 and 4. So in equation 1 we have I1, I2 and V1, and equation 3 has also I1, I2 and V1. So we will reshuffle the equation 1 in the form of equation 3. So in equation 1, I1 minus G12 I2 equal to G11 V1. So V1 is 1 over G11 I1 minus G12 over G11 I2. This is equation 5. Now comparing equation 5 and 3, we can write that Z11 is 1 over G11 and Z12 is negative G12 over G11. Now we'll have to modify the equation 2 in the form of equation 4. For that purpose, replacing V1 from equation 5 to equation 2. So equation 2 becomes V2 equal to G21 into 1 over G11 I1 minus G12 over G11 I2 plus G22 I2. So rewriting this equation, V2 is G21 over G11 I1 plus G22 minus G21 into G12 over G11 I2, or V2 equal to G21 over G11 I1 plus this G22 into G11 minus G21 into G12 over G11 I2. Now this is equation 6. Equation 6 has V2, I1 and I2. Equation 4 has V2, I1 and I2. So by comparing equation 4 with equation 6, we can write Z21 equal to G21 over G11 and Z22 is G22 into G11 minus G21 into G12 over G11, and G22 into G11 minus G21 into G12 is nothing but the determinant of G matrix denoted by del G, and in denominator we have G11. So this is GT, in fact Z22 in terms of G parameters. Now we will write the conditions for a reciprocal two-port network or two-port circuit. Condition for reciprocal two-port network is V1 over I2 when I1 is 0 must be equal to V2 over I1 when I2 is 0. In terms of Z parameters, it is Z12 must be equal to Z21. Now, we will write the condition for reciprocal two-port circuit in terms of G parameters. So, we will simply write these Z parameters in terms of G parameters. So, Z12 is negative G12 over G11 and Z21 is G21 over G11. So this will give G12 is negative G21. So this is the condition for reciprocal two-port network in terms of G parameters. Now I'll write symmetrical two-port network. Condition for symmetrical two-port network or two-port circuit. And the conditions for symmetrical two-port circuit is V1 over I1 when I2 is 0 must be equal to V2 over I2 when I1 is 0. In terms of Z parameters, it is Z11 must be equal to Z22. Now to write the condition for symmetrical two-port network in terms of G parameters, we will replace Z11 and Z22 in terms of G parameters. So Z11 is 1 over G11 and Z22 is G11 into G22 into G12 G11 into G22 minus G12 into G21 over G11. So G11 into G22 minus G12 into G21 is 1, or simply the determinant of G matrix must be equal to 1. So this is the condition for symmetrical two-port network in terms of G parameters. Now let's find out the G parameters for this two-port network in which a resistance R is connected between terminals 1 and 2. Voltage of port 1 is V1, current is I1. Voltage at port 2 is V2, current is I2. So to write the G parameters for this circuit. Let us write the equations for G parameters, which is I1 equal to G11 V1 plus G12 I2. This is first equation, and the second equation is V2 equal to G21 V1 plus G22 I2. Now, by writing by applying KVL KCL, we will write two equations in the form of equation 1 and 2. So from this path we can see that I1 is negative I2. So rewriting this equation, I1 is 0 V1 minus 1 I2. So this equation has I1 V1 I2. Equation 1 has I1 V1 I2. So by comparing equation 1 with equation 3, we can write G11 as 0 and G12 is minus 1. Unit for G11 is mho. Now let us apply KVL in this loop. Rise in voltage, in fact, in this way. Rise in voltage V2 and then drop across R is RI2 and then drop again V1. So this V2 is V1 plus RI2. This is equation 4. It has V2, V1 and I2. Equation 2 has V2, V1 and I2. So by comparing equation 2 with equation 4, we can write G21 equal to 1 and G22 equal to R and its unit is ohm. So that's how we write the G parameter for this given circuit or given two-port circuit. Now let's take another two-port circuit in which 1 and terminal 1 and 2 are short circuited, 1 dash and 2 dash are also short circuited, and the resistance R is connected across 1 and 1 dash. Voltage at port 1 is V1, current is I1. Voltage at port 2 is V2, current is I2. Now again writing the two equations for G parameters. I1 equal to G11 V1 plus G12 I2 and V2 is G21 V1 plus G22 I2. Now by applying KVL KCL, we have to write two equations in the form of equation 1 and 2. From the circuit we can see that 1 and 2 and 1 dash and 2 dash are short circuited. So the voltage V1 is equal to V2. So V2 is equal to V1. Now rewriting this equation, V2 is 1 V1 plus 0 I2. This is equation 3. It has V2, V1 and I2. Equation 2 has V2, V1 and I2. So by comparing the two equations, equation 2 and 3, we can write G21 as 1 and G22 as 0 ohm. Now we have to write the another equation. Current through resistance R is I1 plus I2. So by applying KVL in this loop, we can write the equation V1, rise in voltage V1 and then drop across R, which is R into I1 plus I2. So V1 minus RI1 minus RI2 is 0. So RI1 is V1 minus RI2. So I1 is 1 over R V1 minus R over R, which is 1 I2. Now the equation 4 has I1, V1 and I2. Equation 1 has I1, V1 and I2. So by comparing equation 1 with equation 4, we can write G11 as 1 by R mho and G12 equal to -1. So that's how we find the G parameters for this given two-port circuit. Now let's do the analysis of terminated two-port circuit. Analysis of terminated two-port circuit. Again, terminated two-port circuit means port 2 is terminated at some load impedance. This is two-port circuit. Port 2 is terminated at load impedance ZL. Voltage at port 2 is V2. Current at port 2 is I2. And at port 1, we have external source with voltage VG in series with impedance, series impedance ZG. Voltage at port 1 is V1, current is I1. Now, for this circuit, we have to find out input impedance Zi, which is V1 over I1, output impedance Z0, which is V2 over I2 when Vg is 0, and we also find out the current gain, which is negative I2 over I1 or IL, because IL is negative I2 over II, input current II, and the voltage gain AV, which is V2 over V1 or V0 over Vi, because this V2 is output voltage and this Vi is input voltage. So we will start with this input impedance, but we begin with writing the equation for two-port circuit in terms of G parameters. So I1 is G11 V1 plus G12 I2. This is equation 1. And second equation is V2, which is G21 V1 plus G22 I2. And we have to find out the input impedance, which is the ratio of V1 to I1. Okay, so from the output side, we can see that V2 is negative ZL I2. Now, okay, so we will replace V2 from equation 3 to 2. So we have negative ZL I2 equal to G21 V1 plus G22 I2. Okay, so negative ZL plus G22 I2 equal to G21 V1. So I2 is negative G21 over ZL plus G22 V1. This is equation 4. Now we will replace this I2 from equation 4 to equation 1. So I1 is G11 V1 plus minus G12 into G21 V1 over ZL plus G22. So I1 is G11 minus G12 into G21 over ZL plus G22 V1. So this will give Zi, input impedance, which is V1 over I1, which is equal to 1 over G11 minus G12 into G21 over ZL plus G22. So in this way we can find out the input impedance. Now what we can find, voltage gain, which is ratio of V2 to V2 over V1. Okay, so replacing this I2 from equation 4 to equation 3, we can write V2 as negative negative is positive, so ZL G21 over ZL plus G22 V1. This will give AV, which is V2 over V1, and it is ZL G21 over ZL plus G22. This is the expression for voltage gain. Now let's find out the current gain. Current gain is IL over II or I1. So what is IL? What IL is V2 into ZL. ZL V2. It is IL. And II or I1 is V1 over ZI. V1 over ZI. So AI is ZI ZL into V2 over V1, and V2 over V1 is AV. So by substituting AV here, we can find out the expression for current gain. Now we have to find out the output impedance. So to find the output impedance looking from the port 2, we will first remove the load impedance and make the external voltage source 0. So if external voltage source is 0, then this path is short circuited. Now we will connect the external source with voltage V2 and current I2 to activate the dependent sources of this two-port circuit. Now Z0 is V2 over I2 when Vg is 0. Equations for two-port network in terms of G parameters are I1 G11 V1 plus G12 I2, and V2 is G21 V1 plus G22 I2. So we have to find out V2 over I2. So first of all, this V1 from the input side, V1 is negative ZG I1. Suppose this is equation 3. So replacing V1 from 3 to 1. So I1 is negative G11 ZG I1 plus G12 I2. So now 1 plus G11 ZG into I1 is G12 I2. So I1 is G12 over 1 plus G11 ZG I2. This is equation 4. Now replacing I1 from equation 4 to equation 4 to no. Let us write V1 in terms of I1. So V1 V1 in terms of I2 by replacing I1 from 4 to equation 3. So this becomes minus ZG into G12 over 1 plus G11 ZG into I2. So this is equation 5. Now replacing V1 from 5 to equation 2. So V2 is negative G21 G12 ZG over 1 plus G11 ZG I2 plus G22 I2. So this expression will give the equation for Z0, which is V2 over I2 when Vg is 0, and it is G22 minus G21 G12 Zg over 1 plus G11 Zg. This is the expression for output impedance. So that's how we do the analysis of terminated two-port circuit. For this given two-port circuit, we have to find out the G parameters. So let us write the equations for G parameters. I1 is G11 V1 plus G12 I2. This is equation 1, and second equation is V2 equal to G21 V1 plus G22 I2. This is second equation. Now in this circuit we will apply KVL KCL to write two equations in the form of equation 1 and 2, and by comparing those two equations with equation 1 and 2 we can find out the 4 G parameters. So let's start solving. Current coming at this node is 4Ix. Current coming through the port 2 is I2. So current through this 1 ohm resistance is I2 plus 4Ix. Now at this node, let us apply KCL. Current entering is I1. Another current is entering I2 plus 4Ix, and leaving current is Ix, so equal to Ix. So now I can write I1 plus I2 as 1 minus 4Ix, in fact Ix minus 4Ix, which is minus 3Ix. So I can write Ix as negative 1 over 3 I1 minus 1 over 3 I2. This is equation 3. Now let us apply KVL in this input loop. KVL, which is V1, rise in voltage, then drop across 1 ohm resistance is 1 I1, and then drop across this 2 ohm resistance is 2 Ix. Now replacing Ix from equation 3 to equation 4. So equation 4 is now V1 minus I1 minus 2 into minus 1 over 3 I1 minus 1 over 3 I2. So V1 minus I1, and then minus minus plus 2 by 3 I1, then minus minus plus 2 by 3 I2. So V1 2 by 3 minus 1 is minus 1 by 3 minus 1 by 3. So this is minus 1 over 3 I1 plus 2 by 3 I2. So 1 by 3 I1 is V1 plus 2 by 3 I2, or this equation is I1 equal to 3V1 plus 2 I2. Now this is equation 5. It has I1, V1 and I2. Equation 1 has I1, V1 and I2. So by comparing 1 and 5, we can write G11 as 3 mho and G12 equal to 2. Now let's write another equation which contains V2, V1 and I2. For that purpose, let us apply KVL in this loop. Rise in voltage V1, then drop across 1 ohm resistance, which is I1, then rise in voltage in 1 ohm resistance is 1 into I2 plus 4Ix, and then drop V2. So V1 minus I1 plus I2 plus 4Ix minus V2 equal to 0. we need to have V1, I1, I2. In fact, V2, V1 and I2. Okay. So, V1 minus I1 plus I2, and this Ix is replaced by equation 3. So, this will give minus 4 by 3 I1 minus 4 by 3 I2 and then minus V2 equal to 0. So we have V1 and minus 1 minus 4 by 3 is minus 7 by 3 I1, and 1 minus 4 by 3 is minus 1 by 3 I2 minus V2. Now we will replace this I1 from equation 5. So V1 minus 7 by 3, I1 is replaced by 3 V1 plus 2 I2. Then we have minus 1 by 3 I2 minus V2 equal to 0. So V1 minus 7 V1, and then we have minus 14 by 3 I2 minus 1 by 3 I2 minus V2. So 1 minus 7 is minus 6 V1, and then minus 14 minus 1, which is minus 15 by 3. Minus 15 by 3 is minus 5 I2 minus V2 equal to 0. So V2 is simply minus 6 V1 minus 5 I2. Now this is equation 6, and equation 6 has V2, V1 and I2. Equation 2 has V2, V1 and I2. So now we can compare equation 2 with equation 6. This will give G21 equal to minus 6 and G22 is minus 5 ohm. So that's how we find the G parameters for the given two-port circuit. Now, here we have evaluated the G parameters by writing the two equations in the standard form, and by comparing the equations um, we reached at the final result. Now there is another method in which by making V1 0 we can find G12 and G22, and by making I2 0 we can find G11 and G21. So let us try that method also, and from that method we should get the same result. So first let's make I2 0. This will give G11, which is I1 over V1 when I2 is 0, and G21, which is V2 over V1 when I2 is 0. So if I2 is 0, it means no current is coming from the terminal 2 and no current is going out from this terminal. So voltage across 4Ix is simply V2. This is the voltage across for 4Ix. So current here is also 4Ix. It means this Ix is now I1 plus 4Ix, or Ix minus 4Ix is minus 3Ix equal to I1, or I can write Ix as minus 1 over 3 I1. Now we have to write the ratio of I1 to V1. So apply KVL in this loop. V1, rise in voltage V1, and then drop across 1 ohm resistance, and then drop across 2 ohm resistance, which is 2Ix. Now replacing this Ix from equation 1, so this will give 2 by plus 2 by 3 I1, and 2 by 3 minus 1 is minus 1 by 3 into I1. So V1 is 1 by 3 I1. So I1 over V1 is simply 3. So I1 over V1 when I2 is 0 is G11, which is 3 mho. Now we'll find out G21, which is the ratio of V2 to I1. So applying KVL in this path, so rise in voltage V1, and then drop across 1 ohm resistance is I1, and then rise across 1 ohm resistance is 4Ix, this, and then drop V2 minus V2. So this V1 minus I1, replacing Ix from equation 1, this will give 4 by 3 I1 minus V2. Okay, so minus 1 minus 4 by 3 is minus 7 by 3 I1 minus V2 equal to 0. Now replacing this I1 equal to 3V1. So V1 minus 7 by 3, I1 is 3V1 minus V2. So this is V1 minus 7V1 equal to V2, and 1 minus 7 is minus 6V1 equal to V2. So V2 over V1 when I2 is 0, this is equal to G21, and this G21 is minus 6. This is the second parameter. Now let's check the answers. G11 is 3 and G21 is minus 6. Okay. Now we'll find out the remaining two parameters. Here we will make V1 0. This will give G12, and G12 is I1 over V1 equal to G11 I1 plus G12 I2 when V1 is 0. And we can also find G22, which is V2 over I2 when V1 is 0. So let us make V1 0. If V1 is 0, then these two terminals are short circuited. Now we have to find out the ratio of I1 and I2. So current here is I2 plus 4 Ix. Okay, so by applying KCL at this node, we can find the relation of I1, I2 and Ix. So I1 current entering, another current is entering I2 plus 4 Ix, and this leaving current is Ix. So I1 plus I2 is 1 minus 4, which is minus 3 Ix. So Ix is minus 1 by 3 I1 minus 1 by 3 I2. This is equation 1. Now apply KVL in this loop. This will give minus I1 drop across 1 ohm resistance, and then drop across 2 ohm resistance, which is 2Ix. Now replace Ix from 1 to this equation. Minus I1 minus 2 into minus 1 by 3 I1 minus 1 by 3 I2 equal to 0. So minus I1 plus 2 by 3 I1 plus 2 by 3 I2. So 2 by 3 minus 1 is minus 1 by 3 I1 and plus 2 by 3 I2. This will give 2 by 3 I2 equal to 1 by 3 I1. So 2 I1, in fact 2 I2 is equal to I1. So I1 over I2 is G12 I1 over I2 when V1 is 0 is equal to 2. I1 over I2 is 2. Now let's find G22, which is V2 over I2. For that purpose, let us apply the KVL in this loop. Rise in voltage V2 and then drop across 1 ohm resistance, which is minus I2 plus 4IX, and then drop minus 2IX, drop across 2 ohm resistance. So this is V2 minus I2 and then minus 4IX, minus 2IX is minus 6IX. Now let's replace Ix from equation 1 to this equation. So V2 minus I2 minus 6 into minus 1 by 3 I1 minus 1 by 3 I2 equal to 0. So V2 minus I2, then minus minus plus 6 by 3 is plus 2 I1, and then minus minus plus 6 by 3 is 2 plus 2 I2. So V2, 2 minus 1 is plus 1 I2, then plus 2 I1. Now what is I1? I1 is 2 I2. So I1 is 2 I2. We have replaced I1 from I1 equal to 2 I2 from this equation to this. So V2, 2 into 2, 4 plus 1, 5, I2 equal to 0. So V2 is minus 5 I2. Now G22 is V2 over I2 when V1 is 0 and it is equal to minus 5 ohm. So by finding out the G parameters individually, we are getting the same answers. So in this way we can find out the G parameters of two-port network, and you can use any of the two methods whichever suits you. Thank you.